welcome everybody. Thanks for coming to our talk. So we're going to be talking about optimizing Spring Boot applications for Docker. So just to introduce myself, my name is Mike Thompson. I'm a senior software engineer with IBM. Been with IBM for 15-ish years now. I've worked on a lot of different stuff. I've worked on the Linux kernel over the years. I've worked on WebSphere, Open Liberty, a couple other open source projects. But recently I've been working on Spring in IBM. So with that, I'm here with Graham Charters. So Graham.
Hi. So I'm Graham Charters. I'm a senior technical staff member in IBM. I've been in IBM for over 20 odd years, which is a bit too long. So I've worked in the app server organization probably for about 8 years, and more recently I've been coming out and doing more conference type sessions and working with developers. So before we get into the technical side of things, I'd like to invite you to a party. So there's free beer. I'm pretty certain there's an Irish pub in every city in the world, but we're in the Irish pub in Antwerp, which is near a lot of hotels. So hopefully if you're in one of the hotels near the central station, you can come and pop in and have a beer. You need to register. It's an Eventbrite URL ultimately, and hope to see you there. I don't think we can fit all of you in though, so yeah, be quick. All right. Okay, so Mike's found the animations. Great, thank you. So
put it in for a laugh.
Yeah. So the talk, I'm going to do the intro part where I'll talk a bit about Docker and talk about some of the things about Docker and what you might want to optimize and so on, and finish off with a kind of example. And then so I'm the problems person. I'll tell you about all the things, all the problems, and then Mike will tell you about how to fix them all. So I'll spend about 5 or 10 minutes, and then I'll sit down and enjoy the rest of the talk. Okay, so where to start? Spring Boot with Docker. So this is an example Dockerfile, and this is the example Dockerfile from the Spring Boot Docker guide. So people familiar with this? I can't see your hands anyway. Yep, yeah, we've got some hands, excellent. So quite a few people are familiar with this. Okay, so it works fine. So what's wrong with it? Okay, so in order to understand how we might improve it, potentially, we need to understand a little bit about Docker. I would imagine a few people know a bit about Docker. We're only going to talk about the relevant bits, though. So if you're interested in learning about C groups and namespaces and how Docker does all those isolation things, then we're not going to cover any of that, I'm afraid. So yeah, don't leave, but stay here. And we'll only talk about the relevant bits. So what are the relevant bits? So let's start with what you do when you use Docker to build this Spring Boot application. We're using the pet clinic. Apparently Mike was in a talk yesterday when the speaker said, shall we use the pet clinic example? And everyone went, no. So it was too late for us to change our examples, I'm afraid.
Next time.
Yeah. So you start out with your Docker file. And you've got a command if you want to build it. So you can do docker build -t and then pass in a bunch of arguments and so on. So let's break it down a bit. So the first part, the from. So this is essentially saying what I'm building off. So the nice thing about Docker is people build lots of images. You can then build or stand on the shoulders of those images. You can build from those images. Now, when you do a from, you're inheriting everything from that image. So whatever somebody's put in there, you're getting that. We'll ignore the kind of volume and the arg. Those are kind of boilerplatey things for this particular Spring example. The next thing is a copy. So the copy is copying the jar file, which you've passed in as a name, and copying it to app.jar so that it has a name that it knows for the next example. And whenever you do a thing like a run or a copy or an add in a Docker file, then that creates a new layer. So here we've got a new layer in our Docker repository. And so the last thing, when you're doing your build, in this example, we're going to name our Docker image. We're going to call it Spring Pet Clinic, and we're going to tag it Devoxx in this particular example. And we're passing in as an argument the jar file that we want, so the Spring Boot jar file. Okay, so that's all I'm going to teach about Docker. Hope that was enough. It's enough for this talk, thankfully. So what do we need to consider? So you saw the from in the example. The from, where you from, or what you from, has a huge influence on your image. There's no encapsulation there. So if somebody changes what's in that image, you inherit those changes. They might remove something. So recently one of my Docker files broke because the thing I was fromming from removed its unzip. So I was relying on unzip being in that image, and my Docker build broke, and I had to go and sort that out. The other thing to be aware of is the thing you from. At runtime, it has characteristics. If you're fromming something that contains a JVM, then you inherit the behavior of that JVM. Next, layers are cached. So if you've been doing Docker builds, you'll be well aware of this. So when I do my Docker build, the first time it takes forever as it downloads all the prereqs and so on, all the layers that they're dependent on. And then the next time around, it's really quick because everything's cached for you. However, if you change any of those layers, or if somebody changes any of those layers that you depend on, then that layer that gets changed gets rebuilt, and then all the layers that depend on that layer also get rebuilt. And the last one is deleting things from lower layers doesn't make things smaller. So the thing about the layers, those are they're virtual file system layers. And so when you build from those things and you do new commands that create new layers and so on, you're just adding. It's always additive. So if you actually do a delete in a later layer, you're just masking what's below. So your images only ever get bigger. OK, so let's go back. We've done the Docker 101. Let's go back to this Dockerfile. So it works. So what's wrong with it? So technically nothing, because it works. But let's take a look at the layers. OK. So we'll do that. In order to do that, we're going to do a build. So we're going to demo time. Wrong way. There we go. All right. So let's start by building this. So I've got the Dockerfile here. So if I just do, yeah, we can see the Dockerfile. So I'm now going to build this Docker image. OK. And you can see we've got some of the layers cached already, so that's been built. And we're going to run. So we're going to run that Docker image. So start the container, everything's going to run. Let's go and hit the browser. And there you go, there's the Pet Clinic application running. So you've probably seen that many times over. All right, so let's have a look at the images. And we can see this is the one that we just built 43 seconds ago, and it's 141 megabytes in size, which is kind of okay, not too surprising. So let's have a look at the Docker history. And there we go. So the copy command in our Dockerfile has resulted in a layer of 38.7 megabytes. OK, so we saw that the image was 141 megs, and that the Docker layer that we created, the Docker layer we created was 38.7 megabytes. And in there are your classes. So in that particular, if you're familiar with the Pet Clinic application, do you think there are 38.7 megabytes of files in there?
Not my files.
All right, so hopefully you got a reasonable understanding of Docker and how layers work and images work. And Mike's going to show you how to improve things.
Okie doke. So as we said, we don't have 38 megabytes of classes that are actually my classes, right? The app layer, the app code that constitutes Spring Pet Clinic is quite a bit smaller. So let's take a look at a different way to construct a Docker image. And this is actually a few weeks old, 4-ish weeks or so. And there's a new point of view out on the Spring Docker guide that talks about a different way to structure your Docker file so you can have a more optimal build. So let's take a look at that. So previously we had the single line that copied in the entire jar file, right? This approach is different. And to help you understand why it's different, why it is potentially better for your application, let's actually do another build. All right, so I am going to steal a bit and check out a Git branch. And I've already got, let's ignore any local hacks. I've already got a Dockerfile already configured that looks like what we just talked about, right? So here are my copy lines, and that's going to change the way that my application or my Docker image is ultimately layered. And let's just do a Maven build for this. So I'm taking advantage of a Maven plugin that is going to help me package up my application, right? So it's going to do all the standard stuff. It's going to, compile my Spring application, run the tests if I didn't skip the tests, and it's going to critically invoke the Docker daemon so that it will actually do a Docker build. Now, the step that's happening under the covers here that's actually quite important is it's generating the files that we need for that dependency, and we'll take a look at that right here as the build finishes. So you can see in our build output that I now have the multi-copy lines, and where that's coming from, if we take a look at the Dockerfile again, is it's coming from my target dependency directory. Now, where did that directory actually come from? If I look inside target, I've got my dependency directory, and that's actually happening as part of that Docker build. When I do that package, it's extracting my Spring Boot jar and then taking that extracted set of components from that jar and now shoving it into the Docker layer. So why does this matter? Well, if we take a look at our images again, you can see that this is the image that we just built, right, 35 seconds ago. Ever so slightly bigger, 1 megabyte bigger than the image that we just built. But if we interrogate the history, so we can actually inspect the layers. It would help if I typed. Now what you can see is instead of the one layer that we had with the 38 megabytes, we actually have now 3 layers, and I've got 98K or 988K, which is actually the classes that comprise the Spring application. So the majority of that 38 megabytes is actually the libraries that I'm dependent on. They're not the things that I as a developer am building. So by packaging all that stuff together in one layer, every time I rebuild and every time I push, I'm pushing up a whole bunch of stuff that doesn't actually change. So I'm not really layered in a way that optimizes me for iterative development. And that's really the key point here, right? If you are in a shop, if you're working on an application and you change it once a month, this might not save you a whole lot. If you're in a shop that's trying to get to iterative development, or you're doing iterative development and you're changing images weekly, daily, or even, more frequently than that, hourly or what have you, this actually can add up to be quite a lot of wasted space. And Spring Pet Clinic is, admittedly a very small sample. In the real world, these jar files are going to be quite a bit bigger, and that has a multiplicative effect as you continue to do these rebuilds and do these pushes. All right. So we talked about our layers and the increase in size. The key point, again, is that your classes, those are the things that you're actually changing. That's what you're rebuilding. That's what you're recompiling. That's what you want to be repackaging. That's where you want your stuff to be, right? You want your stuff to be at that top layer. You want your classes to be the leaf of the dependency tree. You want them to be the very last thing. Because, again, as you rebuild, as you repush, you're ending up packaging a whole bunch of stuff you don't need. So that's why layers really matter, and we want people to think about the way that you structure your Dockerfile, because it does add up in the real world, right? By having a better layer architecture, by having a better layering strategy, you can actually take advantage of that build cache, and you can build the smallest possible thing that you need to. You also get faster deployments because you're pushing less bits over the network, right? Docker is very, very clever with its caching strategy. You can almost think of it in a way like Git, right? Everything in Git has a SHA. All the layers in Docker have a SHA, and it knows when it can reuse things. So it's one of the things that makes Docker great for stacking applications on, on a shared host. And at the end of the day, if you're hosting your own private Docker repository, you're going to end up using less space, which will save you, in the cloud for storage costs. So how do you actually get there? Well, Graham and I have been working on a Maven plugin called Boost. One of the things that the Boost plugin will help you do is actually generate these Docker files for you. So if you have a Spring Boot project that you have not Dockerized yet, you can just plug in some lines in your POM XML and basically run the boost Docker build target. If you've already got a Dockerfile, that's great. It will honor it and do exactly what that Dockerfile is currently set up to do. If, on the other hand, you've never created a Docker image from the Spring Boot project before, you can ask it to create a Dockerfile for either a jar strategy or a class path strategy, and it'll do the right thing and produce the actual image for you. So just to do a kind of a quick review, there's two prevalent strategies for doing your Dockerfile with Spring Boot. There's the sort of tried and true jar strategy that's what has been used time and time again. And there's this newer class path strategy that really takes advantage of the layering strategy that Docker provides you in a way that we previously haven't really focused on. There's a few gotchas to call out here. One of the nice things about the jar strategy and the way that it's been sort of implemented and evangelized through the guides is you don't really have to worry about ever editing that Dockerfile. You can copy paste it. If you try and do that with the current guide structure, you do have to remember to update the main class, right? So you want to point that to your Spring start class. So if you go out to the guide, you'll see hello.application. Your application start class is probably not hello.application, so you need to be able to update that. The Boost Maven plugin will do that for you when it populates that Dockerfile. So, are we done? Not really. We've said that the Dockerfile structure matters, right? You've got the CI/CD approach. You've got the easy, I don't change this application often that much. But we did talk about where you're from matters, right? Or what you from matters. Because that really will change the way that your application behaves. And in some cases, you're going to have really good control over where you're from. In other cases, you might not, depending on your target Kubernetes environment, depending on reality of enterprise development. You might have specific requirements within your organization that say, well, you have to use the following blessed images, those kinds of things. I'm not going to tell you how to get around that, because if you have like a corporate requirement or you have a customer that requires you to use a particular image, then so be it. But if you have the flexibility to pick where you're from, you need to think about a couple things. So in the cloud, right, that's where we all want to be. Everything costs money. So small footprint means less money because we pay for the resources that we use. Faster startup means less money because you can get to doing the job quickly. And if you have more throughput, you can do more work in less time. And the reality of the cloud is, it's a lot about economics. It's a lot about developer productivity. It's a lot about making your life as a developer easier because you don't have to care about, all the stuff that you used to care about. But you do have to be conscious of the impact of the decisions you make. So I'd like to introduce something called Eclipse OpenJ9. It is part of the Eclipse Foundation. It's actually built on some IBM technology and IBM Java that's been around for over a decade. We contributed it to the Eclipse Foundation last year, and it is an entirely open source approach to the Java virtual machine. So it is an alternate to the hotspot JVM. And I'll pause and say, OpenJ9, the name J9, has absolutely nothing to do with Java 9. It's a very unfortunate coincidence that many people get stuck up on. I will not go into the details of why it's called J9, but know that OpenJ9 can be used with Java 8 and Java 9, 10, and 11. So it's an alternate runtime environment, if you will, for your Java application. And it was originally designed to run on mobile phones. So remember those old Nokia that probably everyone who had a mobile phone had? IBM built Java to run those applications on that phone. So it was designed from the very beginning to have a maniacal focus on really fast startup and really low memory usage and high performance, because let's admit it, a phone is a constrained environment. Now, the cloud is not a phone, but what you want out of your applications, what you want out of the cloud is you want to have that minimal cost, right? So you want to treat it as often as you can as a resource-constrained environment, because that means you're not going to be greedy and consuming a lot of resources, which you're ultimately paying for. So really, it's really, really easy to use OpenJ9. All I'm going to do is change my from line, right? So I was froming the official OpenJDK images out on Docker Hub. Here I'm changing my image to pull from the adopt.jdk space. The adopt.jdk, just to go back 1 minute and introduce that, Adopt OpenJDK is a community-driven project. They are doing freely available open builds of both OpenJDK with Hotspot and OpenJDK with OpenJ9. You can go to adoptopenjdk.net and go out there and start downloading and playing with your favorite VM. They have community builds out on Docker Hub for both OpenJDK with Hotspot and OpenJDK with OpenJ9. They don't quite yet have an official image for OpenJ9, but they are working on that. It's a community-driven process. So here in my Dockerfile, I'm going to switch this over to use the OpenJDK community build for OpenJDK 8, which is Java SE 8, with OpenJ9. And let's take a look and see how we do this build and do a little bit of a compare. All right. So similar to before, I'm going to check out, but now I'm going to check out my OpenJ9 branch. And let's just take a look at the Dockerfile. Bring it up a bit. So you can see here that it looks identical to the class path strategy that I was using earlier, where I was basing it on the OpenJDK build for Hotspot. Now I just changed the from line. That's literally all I'm changing, is just where I'm pulling my image from. And I'm going to take advantage of the Boost plugin to do a Docker build. So that's going to run. It's going to build my image. We're going to be able to take a look at that in just a sec. And what you'll see is the same layering strategy, but it's going to have a different baseline. And we're going to talk about what that means and what's coming down the line. All right, so if I look at my images, you can see this is the one that I just built, right? That's 3 seconds old. It's a bit larger. Why is it a bit larger? Well, at the moment, the OpenJ9 builds are not based on Alpine Linux, right? If you look at the builds that we used in the Dockerfile previously, we were using the official OpenJDK build based on Alpine Linux, which is a really, really tiny Linux. If we look at the history, so we can inspect the layers of the class path with OpenJ9, you can see that I've still got my itty-bitty class layer at the top, but I've got a significantly fatter base, right? Alpine, I think, is like 4 or 5 megs. This one's 115. So that's something that the community knows. They're working on moving or adopting a Alpine Linux-based set of Docker builds, and when they do that, you'll be able to take advantage of that. But for the sake of this talk, remember what really matters is the layering that you are subjecting upon yourself and the way that you're structuring your Spring app. So yes, the image is bigger. Yes, that's a bigger initial push, but as I do my iterative development, as I do my iterative pushes, I'm going to be pushing that 1 megabyte layer, so the 115 at the base is pretty much reusable. All right, so now I've got a couple Docker images. Let's do a quick comparison. So I'm going to use Docker Stats for this. Docker Stats is kind of like top for Docker if you've never used it. It's actually a pretty nice tool. I recommend that you play with it. And what I'm going to do is I'm going to spin up 2 Docker images side by side, both Pet Clinic. The only difference is the from line that they're built. So I had previously built and tagged on the red side, red versus blue, the class path with Hotspot and class path with OpenJ9. And they're both going to spin up, they're both going to start, and it's going to take a couple seconds because I'm pounding on my hardware here. But the key takeaway here that I want to share with you is that with doing nothing other than changing where I'm from, I get significant memory savings for my Docker container running with OpenJ9, right? It's roughly 60% smaller than the default heap size, the default memory usage that you get out of Hotspot. And the reason for this is because, remember, OpenJ9 was built with constrained environments in mind. It was designed to run on a tiny little phone. Because of that, there were certain design decisions that went into the architecture of OpenJ9, which makes it really, really ideal for containers. And you might notice that the CPU utilization is a little bit higher. Well, what's going on there? Well, OpenJ9 is currently trying to optimize and JIT pretty much all of the stuff that it can guess about right now. And good thing it happened while I was still talking about it. You see the CPU utilization just drop below the sort of quiet time usage of hotspot. So OpenJ9, really nice for containers, because you get some pretty significant memory savings out of the box with needing to do really not a whole lot. Now, I will say there is the one caveat, which is if you are using your JVM arguments to tune your heap, right? If you're tuning a bunch of stuff and you're leveraging hotspot specific settings, those are not going to map to OpenJ9. However, we find in practice that if you are doing that, you're usually aware of the fact that they're hotspot specific, and you would know to be looking for the OpenJ9 equivalents. Just something to be aware of, because I don't want anyone to stumble across that. So you get really good memory savings with just changing your from line in Docker, or if you're doing this on a non-Docker environment, you're playing in VMs or something, you can just go to adoptopenjdk.net, download the tarball, and extract. I don't talk about it here. I'm very happy to talk about it if anyone has questions after this about increasing the startup time with OpenJ9. There are some tuning flags that you can set that will essentially trade off peak throughput options for faster startup. And basically what that looks like is this graph. We've done quite a bit of analysis between hotspot and OpenJ9 just to see how do these things compare. And the blue line is the performance results for using just OpenJ9 with no tweaks. The red line being hotspot. And the sort of key takeaway here is that OpenJ9 and hotspot basically reach the same amount of peak throughput. OpenJ9 just gets there faster. And again, that goes back from the legacy of it being, or the history, I should say, because legacy is a dirty word, the history of it being built for those constrained environments. The green line, where it starts up really quickly but then plateaus, is that trade-off that I was mentioning, where you can say, if I have a short-running process, right, I'm super microservices and everything's auto-scaled and nothing lives for more than a minute, then that's a really compelling option for you to play with, because you can get there and run your job faster. So we've got 2.5 minutes left according to my screen. So what are all the things that we didn't talk about, right? 30 minutes is not a whole lot of time to cover the giant world of Docker and Spring Boot. So we did not talk about here the difference between hotspot, OpenJ9, Graal VM, and Graal native, right? I'm up here making claims about, hotspots are OpenJ9's awesome. As always, do your own testing, validate your stuff. There was an excellent talk yesterday on Graal, both the Graal VM and Graal native. If you did not get a chance to see it, I highly encourage you to take a look at that. There's some really interesting stuff going on in that space. We have not talked about the things that you need to pay attention to when you're building cloud native applications. So what API should you be using? What are your processes that you should be following around build and DevOps, CI/CD pipelines? How you design your application, how you structure all that stuff. All that 12-factor stuff, didn't have time here, but again, very happy to talk to you about any of that. We didn't really cover documented best practices that Docker already publishes. Things like running as non-root is a really good idea, and they have some very good documentation for how you do that. And if you're in the business of building your application inside the container, and I've done a talk previously about this, there's a really important thing now in Docker called multi-stage builds that allow you to basically build something in a container and then selectively bring the pieces over that you care about, so that you don't end up with your final image having like Maven and Gradle and apt-get and all the stuff that you don't really need for your app in that final thing. And then lastly, there's an excellent blog post out on spring.io about running Spring Boot in a container. It has this excellent section on tweaks. It goes into all the sort of like fiddly bits and optimizations that you can set further. These slides will get posted, on SlideShare or something like that, so you can go and follow these links. So let's summarize. Layer your Spring Boot application in Docker, right? You want to do this in a way that's going to minimize your cache, or maximize your cache and maximize your reuse while minimizing your build churn. The Boost Maven plugin can help you do this if you just want to use something easy and get started. I will say, like everything, your mileage may vary. If you are iterating on a Spring Boot image and what you're changing 90% of the time is like static content, the way you package your classes is not going to save you. You do actually want to think about how is my application built, how is my application structured. And then lastly, understanding the contents and characteristics of your from really matter. I'd encourage everyone to take a look at Eclipse OpenJ9. It's a really easy memory and performance win for what is about 15 characters of changed Dockerfile. And that's it. Thank you very much for the time. Remember to rate the session and have a great rest of Devoxx. Thank you, everybody.